Section 4.5, integration by substitution. Okay, so let me ask you this. If I ask you to find the derivative of this, notice x has the function g applied to it, and then the function f is applied to it. So we would need our chain rule to derive it. Derivative of the outside function, keep the inside the same, and multiply by the derivative of the inside function. Okay, plus c, the derivative of any constant is 0. And now let's use our definition that the derivative of big F prime of x is equal to little f of x. So I'm going to replace that. Okay, now let's use what we know about the derivative and the antiderivative. They're inverses of each other. So now if I ask you what would the integral of this be, and I'll add in my dx to show that I'm integrating with respect to x, then when I move backwards, the antiderivative of this statement should be the original statement that we derived. And then I put in there my plus c, because it's an indefinite integral. We will talk more about this, but let's look at the composition of functions. So we know that the composition is when two or more functions are applied to our variable. So they're in this form, f of g of x, or any letters. Okay, we could have 3 functions applied to the variable. When we derive a composition, we use our chain rule. Okay, we derive, and we worked with this from what I would always say, the inside out. When you integrate a function that uses the composition, so multiple functions applied to the x, then the rule we use is a u-substitution. And this is what our integration by substitution uses, okay, this u-substitution. Now how does that work? So let's go back to this. Okay, so what we choose, we make this substitution, and we take it as the inside function. And the more examples we do, this will make a little more sense. So the inside function here we'll call g of x. Okay, well now let's derive u. So u is written in terms of x, so when I derive u in terms of x, the derivative of g would just be g prime of x. Now I'm going to separate these variables. I'm going to multiply both sides by dx, okay, so that I have all the x's together. And now what I'm going to do, in my original integrand, wherever I see an x, I'm going to replace it with a u. So u, I'm going to replace with g of x, and then du, I'm going to replace that whole statement. So let me go back up here. This is what I'm going to replace with du. And then my inside function is what I'm going to replace with u. So now the integrand becomes f of u times du. Okay, so we've taken away that composition. Now what's the antiderivative of little f? Big F plus c. And now why does it work? Because u, we said, was g of x. So if I make that final replacement, these two are equivalent. So what do we do with any substitution? We replace equivalent functions. So we're going to make our u-substitution to be in terms of x. We then have to derive whatever that function is we chose as u, and then we make the substitution into the integrand, and we apply any rule that we can use. And still, all we have available to us are the power rule and our trig rules. Okay, we haven't learned anything else yet. So let's just practice this. So evaluate each. The antiderivative of x squared minus 9 quantity squared times 2x dx. Okay, inside function. Notice here x is being squared, I'm subtracting 9 from it, and then I'm cubing it. So we're going to call u x squared minus 9, which makes du 2x, and we're going to work with this a little bit. Okay, so now I have my substitutions, and it becomes the antiderivative of u cubed, and then this whole expression becomes du. So now when I integrate it, it's the power rule, u to the 4th over 4 plus c. But remember, your original integrand was in terms of x, so your answer needs to be in terms of x. So we go back and we make that replacement. Now remember, every time you find an antiderivative, you can check it using the derivative. So if you derive this function, power rule, bring the exponent down, subtract 1 from the original, and then by the chain rule I have to multiply by the derivative of the inside. So the 4's cancel, and we are in fact left with the original integrand. X squared times, x cubed plus 5 to the 4th power dx. Alright, so my inside function, I have this expression raised to the 4th power, so that'll be our u. And now the derivative of this is 3x squared, and I'll just put the dx on the right hand side with it. Okay, so now look at what we have. We have 3x squared dx. Well, right now I only have an x squared and dx. So remember, we're taking out all the x's. If I solve this equation for dx, now look at what's going to happen. So I have the integral of x squared. So I'm going to replace the inside with u. X cubed plus 5 is equal to u. And then dx I'm going to replace with this du divided by 3x squared. So look at what happens. The x's cancel out as they should, and now that dividing by 3, we can introduce numbers whenever we need them. So this 1/3 will now just act as a coefficient to our integrand. Applying the power rule, u to the 5th over 5 plus c, and now making our final replacement, 1/15 u to the 5th plus c. And for each of these, please take some time, and if you want to check them, do so to make sure you get the original integrand. So how's this different from the first example? When I went to make my replacement for du, I have exactly what I need. I had 2x times dx. So I was able to make that very direct substitution. On this problem, though, when we took the derivative, it was 3x squared. All we had in our integrand was an x squared and a dx. So we had to account for this coefficient here and make sure it reflected correctly in the substitution. Antiderivative x cubed all over 1 plus x to the 4th quantity squared. Okay, so inside function, x is being raised to the 4th power, and then we're adding 1 to it, and then we're squaring that whole thing. So 1 plus x to the 4th would be u. The derivative of this is 4x cubed dx. Solving this equation for dx, because that's what I'm making my replacement for. So I have the antiderivative of x cubed divided by u squared times du all over 4x cubed. Now at this step, you need to understand that we can only integrate in terms of one variable. Whether it's an x, a u, a theta, we can only have one variable in the integrand. Making the correct substitution will get any x's to cancel. Alright, so that's the check to yourself. We still have our 4 in the denominator, so I'm going to bring that out front. 1 over u squared, I'm going to rewrite that to use the power rule. Now integrating, add 1, divide by the new, and making our final replacement. And u to the first power in the denominator. You can distribute the 4, you can keep the negative in the denominator, or you can just leave it as such. X squared all over the cube root of 16 minus x cubed. Okay, u inside, I'm going to pick the expression that's underneath the cube root. Du is negative 3x squared dx. Solving this equation for dx. Right now making all the replacements that I have. X squared all over the cube root of u. And dx we're replacing with du divided by negative 3x squared. So again, I made the correct substitution because the x's cancel. Negative 1/3 out front. U to the negative 1/3 du. Now we can apply our integral rule. Add 1 to the exponent. Dividing by 2/3 is equivalent to multiplying by 3/2. So negative u to the 2/3 all over 2 plus c. Okay, the 3's cancel each other out, and our exponent is positive, so that expression stays in the numerator. Antiderivative of cosine of 8x. Okay, now look at x. X is being multiplied by 8, and then we're taking the cosine of that expression. So this is a composition, so it needs a u-substitution. What's the inside function? On this example, it'll be 8x. So du is equal to 8 dx. Solving this equation for dx, I would divide by 8 on both sides. So cosine of u times du divided by 8. The u substitution, there's no need to cancel any more x's out. We'll just bring this coefficient out front. Antiderivative of cosine is positive sine plus c. And as a check to yourself, derivative of sine is positive cosine. So then just making our final replacement, replace u with 8x, and then add c to it. Let's look at one more trig example. Square root of tan x times secant squared x. Okay, so technically we could argue that there's two inside functions here. You need to choose one that you can make a proper u substitution and eliminate all the other x's. Let's start with, if I picked u to be secant of x, the derivative of that is secant tangent. So if I make my replacement and I put u squared, well, I wouldn't be able to eliminate any other x's from my statement here. If I choose u to be the tangent of x, then du, the derivative of tangent, is secant squared. Now look at my original integrand here. I'll go back to the top one. I'd have the integral square root of u, and now secant squared x dx is my direct substitution for u. Alright, I'm going to assign a few problems. We'll start in class with that tomorrow. Page 306, numbers 1 through 6. Evaluate each antiderivative. And then numbers 47 to 59. odd only. Try to check your solutions, please.